Okay, I have a little bit of maybe bad news for you.
Oh, no.
So I
Also,
don't.
it should be a third period at this time. B lunch will begin at 11:50. Our B lunch always are G hall. B is in boy and A hall. Again, G, B, and A will be going to B lunch at 11:50. It should be in class at this time. Thank you.
Okay, it's not too bad of news, but here's what the news is. So you all know at the beginning of the year, we talked about that this counts as an advanced course. So as of this semester, the below 50 rule doesn't apply. That like we can't give you a grade below 50, that rule is not a thing anymore. So I just want to give you a heads up that if you always wait till the last 3 days when I have to switch all the 50s, everything below a 50 to a 50, that won't happen this semester. But most of y'all are wonderful students that you would never get below 50. Okay. Okay. It's just for all the pre-cal class.
Oh.
Okay, because it doesn't count towards eligibility. So they decided it's just a bit.
Okay. So that for all no.
What'd you say? That's been for AP.
Okay.
But pre-cal now is just like grouped with that. Okay. So that being said, let's go ahead and get started. All of the fall, we did lots and lots and lots of algebra. Okay, now that we're in the spring semester, we're going to do geometry and trig pretty much the whole semester. So if you were not good at this stuff in the fall, you have a fresh start. That all the stuff we're doing this semester is pretty different and it won't hurt you if you didn't do well semester 1. So let's get started with simplifying square roots. Y'all just took geometry last year. So hopefully you remember this a little bit. First thing that you're going to do is you're going to separate your square root into a product where one of the square roots has to be perfect and the other square root I'm going to call the leftover root. Now, when I say perfect, we're going to create a list of perfect squares over here on the left-hand side. Hopefully you have them memorized, but if not, you'll get to use this when you take a test over this unit. So what is the square root of 4? Okay, square root of 9. 3. 16 goes to 4. And now you can tell the pattern, right? It's just going to keep counting up. Okay, so 25, the square root is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so all of those numbers that you've listed out to the left-hand side of your page are called perfect squares because when you square root them, they square root into a perfect whole number. So our goal is going to be to separate into a product of a perfect and whatever's left over. Then you're going to simplify the perfect square root. And then if there's already a new coefficient, you'll multiply by the new coefficient. So let me show you what that means, and then we'll see if you can do it. So let's start with number 1. We want the square root of 50. Now, if you put that in your calculator, the square root of 50 is a decimal. Okay, it is not perfect. So what we're going to do is we're going to look in the list. Okay, for what 50 can divide by that is perfect. Now, you want the biggest number. So what I want you to do is find 50 on the list, and then you're going to work your way up. So what is 50 closest to? 49. 49. Can it divide by 49? Can 50 divide by 36? What about 25?
Yes.
Yes. So you're going to write down 25 times whatever will keep it a 50. So what would 25 need to multiply to keep it 50? 2. Very good. Then from there, you're going to reduce the perfect square root. What is the square root of 25?
5.
5 root 2. Okay. All right, let's do number 2 right next to it. My number is 48. Type it into the calculator if you want. 48 is not a perfect square. So I'm gonna find what 48 is closest to and then work my way up. I'm looking for what number 48 can divide by. So in your calculator, can 48 divide by 36 evenly? No. What about, can 48 divide by 25? What about 16? 16 times what?
3.
16 times 3. And then the square root of 16 is perfect. What's the square root of 16? So it'll go to 4 root 3. Now, if you take a look at the question right below that, do you see that it's still a 48? But this time there's a 10 in front. So let's talk about how would you do that same question if there's already a number in front. Here's what you do. Your 48 would still split into a 16 and a 3. But remember, now there's a 10 in front. I would still square root the 16 because it's perfect. What's the square root of 16? Still a 4 root 3. But then remember, there's a 10 in front. And then what your third step is that you're just going to multiply the new and the old coefficient together to find out what your number is going to be that's in the front. So if it used to be a 10 and I'm timesing that with this 4, what's my new number in the front going to be?
40 square root 3.
40 square root 3.
And that's
it. All right, let's skip down to, let's do number 6. Okay, the number I want to break down is the square root of 200. So I'm going to find the closest to 200 I can get, and I'm going to work my way up. 200 is closest to 196. Will it divide, though, by 196?
No.
Will 200 divide by 169? 144? 121? 100?
Yes.
Yes, 100 times what?
2.
So it's going to be a negative 6 in the front. 100 times 2. Now notice that if 200 is in a square root, when you split, they have to both be in square roots as well. Until the square root of 100 is perfect. What's the square root of 100? So it's a 10 root 2. But then I already had a what in the front?
-2.
Negative 6. And remember, you would multiply those coefficients together to get your new coefficient, which would be what number? Negative 60 root 2. All right, let's do number 8. Number 8, what's the number in the square root we want to reduce? 72. What is closest to 72 on your list? 64 sounds good. And then we're going to work our way up. So can 72 divide by 64? 49? Yes or no? No. What about 36? Yes. 36 times what? So it's going to be 3. 36 times 2. And then I take my square root of 36. Remember, if it's on the list, that means it's perfect. What's the square root of 36?
6.
So it'll be 6 root 2. But then I already had a 3 in front. Remember, you multiply those numbers on the outside together. What would my final answer be?
18.
Very good, 18 root 2. Now, if you take a look at number 9 right next to that, you'll notice that you have 2 square roots and they're multiplied together. Okay, numbers on the outside, you can multiply together. The same applies for numbers that are both on the inside. So for example, the 4 and the 3 can times together. The 10 and the 30 can times together. So what is 4 times negative 3 for the number in the front?
-12.
Negative 12. And then I'll do the square root 10 and the square root 30. What is 10 times 30? 300. Very good. Then you want to see if this can break down by any of the perfect squares in your list. So look back at your list. Okay, 300, you're pretty much starting at the bottom. Okay, what number can 300 divide by that's on my list?
100.
100 is correct. Very good. So I'd have negative 12, 100 root times what?
300.
times 3, so it's 100 times 3. And then what's the square root of 100?
10.
So that'd be 10 root 3. And then remember that that 10 had a number in front of it. It had a negative 12. So I'm going to multiply those pieces together. What will my final answer be?
Negative 120.
120 root 3. Very good. Questions on that? All right, go ahead and turn the page. Now, for multiplication, the square roots do not have to match for you to multiply them. For example, here, I had a square root 10 and a square root 30, and I was able to multiply those together as usual. However, on the next page, you're going to see some addition. You can only add or subtract like terms. So if you'll write that up at the top, please. Okay, you can only add and subtract like terms. Okay, and what I mean by like terms is that the number inside the square root has to match. So I'm gonna put same square root. So for example, when I initially look at number 9, a root 20 and a root 45, I can add those. But if they can simplify, they might simplify to the same type that then you could add them up. So will you please peek back at your list on the first page? I want to break down the number 20. So you're going to start at 16 and work your way up. Can 20 divide by 16? What's the number above that? 9. Can 20 divide by 9? No, what's the next number? 4. Can 20 divide by 4?
Yes.
Yes. So it's going to be 3 in the front, root 4, root 5, because 4 times 5 is 20. But then I can reduce the square root 4 to a what? 2. So it's a 3 times 2 root 5. And then what do I do with the 3 and the 2? Multiply them together. So 3 times 2 means that's really a 6 root 5 plus. Now we're going to break down our root 45 and see if it ends up being the same type. So look back at your list. 45 is closest to 49, and we're going to work our way up. Can 45 divide by 36? No. 45 divide by 25? No. What's the next number? 16? That's a no. What about 9? Yes, 9 times 5. So I'm going to do root 9 times 5. And then what's the square root of 9? It's perfect. It's going to go to a 3 root 5. And now notice that last time I already had a number in front that I had to combine. For this one, I don't, so I'm just going to copy it one more time. Then if I have a 6 root 5 plus a 3 root 5, are they the same type of root? They're both root 5s, and I can add the numbers in the front. So if I have 6 here plus 3 more, how many will I have altogether? 9, and you're going to keep the root 5 the same. Okay, when you are adding, you are only adding those numbers in the front together. Okay? All right, take a look at number 10. This time we have 3 roots. Okay, they may not all break down to the same type, but if they do, we can combine all 3. So let's start with 48. Look back at your list. 48. What can that divide by?
16.
16 times what? 16 times 3. Now, for me, I'm going to break this one all the way down, then this one all the way down, and then this one all the way down. You could do them all kind of at the same time if you want, but I'm not going to. What's the square root of 16? 4. And then can we go ahead and just times, if this is a 4, I'm going to times it by the 5 and get what? 20 root 3. plus, plus. Next, we're trying to break down 150. 150, so let's look back at our list. 150 is gonna be closest to 144. But can 150 divide by 144? No. What's the next number I'm gonna try? Oh, 25 is great. 25 times what? 25 times 6. Don't forget the 2 in the front. Now, if you know your times tables well enough, you can just kind of skip to the answer. That's fine. Okay, then 25, what's the square root? It's perfect. What's the square root of 25? 5, very good. And then I'm going to times it with the 2 in the front. 5 times 2 makes that up 10 root 6. Okay, then last one. We're looking for 243. Okay, this one we may actually have to divide some numbers out. Now, I will give you a little hint. Okay, if your number is odd, then it can't divide by an even. So because 243 is odd, I know none of the evens are going to be wins. That isn't true the opposite way. If it's an odd, it could divide by either one. But evens, sorry, I said that wrong. If it's an even, it could divide by either one. But 243 can only go by odds. So 243, can it divide by 225? No. What's another one I could try? Next odd would be 121. Nope. What's the next odd?
169.
169, I know it can't, so skip that one. 81 times what? 3. And once you get a whole number, that's when you know that you have your pair. So that's going to go to 81 times 3. And then what's the square root of 81? 9. Remember, you have your list. But if this is a 9 and I have to times it by the 5 in the front, what's that going to end up being? 45 root 3. And then out of those choices, notice the root 6 cannot combine with the root 3s, but the root 3s can combine with each other. So if I have 20 and I take away 45, what are these two going to be when I combine them? Negative 25 root 3. And then plus a 10 root 6. Okay? But you can only combine with addition and subtraction if they're like terms, meaning the square root matches. Okay, one more little thing we have to cover, and then we'll be on the first half of y'all's homework. Okay, for square roots, there is a rule that you're not allowed to leave square roots in the denominator. So there's a way for you to fix it. Okay, it says right here, square roots are allowed on the top, but they are not allowed on the bottom. So here's how you're going to fix that. Anytime you have a square root on the bottom, you're going to multiply that exact same square root on the top and the bottom. So for example, on number 11, what square root is on the bottom?
2.
Then I'm going to put another root 2 here and here. Now, let's talk about why. The top is going to be a 10 root 2. Okay, because I already had a 10 up there, and then I times by a square root 2. Here's what's going to happen on the bottom. If you do square root 2 times square root 2 again, you get the square root of 4. But the square root of 4 is perfect. What is it? 2. So when you multiply a square root by its own self, you're just going to keep the number and the square root goes away. So if you multiply a square root by its own self, you're just going to keep the number from the middle, the square root will cross out. Now from here, I have two numbers that are on the outside. That means that I can multiply or divide them. Which one will I do here? 10 divided by 2 is 5 root 2. All right, let's do one more like that. Take a look at number 12. What square root is on the bottom? 6, and we can't leave square roots on the bottom. So I'm gonna put another root 6 on top and a root 6 on the bottom. On the top, I have a 3 root 6. But on the bottom, what's root 6 times root 6 again? Now it's just a regular 6, right? A square root times itself, you just keep the number from the middle. So root 6 times root 6 is just a 6, and then don't forget you had a 2 out there. What is 2 times 6 on the bottom? So that's 3 root 6 over 12. Okay, then from here, if you have numbers that are both on the outside, you can divide them. Now, in this case, 10 divided by 2 came out to 5, and it was great. 3 can't divide evenly by 12, but I can still simplify it. What can 3 and 12 both divide by? What number? 4. So to reduce that, I'm going to divide by 3 on top and on bottom. 3 divided by 3 is now a 1 root 6. 12 divided by 3 is a 4. So your answer would be root 6 over 4. Okay? All right, last one like that, and then we'll be ready, I think, yep, to do a little homework. So take a look at number 15. Okay, I notice I have a square root on the bottom. What is it? Square root 2. So I'm going to put another square root, top and bottom. All right, here's what we have so far. On the top, I have a 4 and a 6 that are both on the outside. Those can times together. In your calculator, what is the 4 times the 6 together? 24. Then multiply the numbers that are both in square roots together. What's root 6 times root 2? Root 12. Because remember, you can times, if they're both on the outside, they can go together. Both on the inside can go together. Now, on the bottom, what's root 2 times root 2 again? Regular 2, right? Because the square root's going to cross out. So I have a regular 2 times a 3. What's that going to be? 2 times 3, that's going to give me 24 root 12 over 6. Okay, now that I have numbers that are both on the outside, what can I do with those? I would multiply if they were next to each other, but what if they're in a fraction like that? Divide them. So in your calculator, what's 24 divided by 6? 4 root 12. Now, if 12 doesn't have a perfect square in it, you're done. Will you peek back at your list and see if the root 12 part of this can break down with any of the perfect squares? Which one? Look at your first couple of perfect squares. Which one can 12 divide by? 4. So it's going to be 4 times what? 4 times 3. And then what is the square root of 4? 2 root 3. But then my 2 already had a 4 in front of that. So 4 times 2 is going to give me what? 8 root 3. Now, let me point out, okay, that this answer isn't wrong. It's just not simplified all the way. So if you get to a point in your homework where it's counting it wrong, look and see if your number in your square root can break down a little bit more. Because if it can, then it's not that it's necessarily wrong, it's just not simplified all the way. Okay? The only thing we're going to add to this is Pythagorean theorem. And I think we only have 3 examples. Would you want to just do it or? Yeah. Okay. All right, go ahead and turn the page. Now that I see it's only 3, I think we can do it. All right, so Pythagorean theorem is the relationship between the 3 sides of a right triangle. So it's a squared plus b squared equals c squared. A and B are going to be the legs of the triangle. And C is called the hypotenuse.
Geometry.
Pretty much, yeah, the whole third quarter. And then remember your hypotenuse is always across from where the 90-degree, the little box is. Okay. So for now, we're gonna just ignore all the labeling of the triangle. You don't really need that for today. Okay, take a look at number 1. What are the legs of my triangle? What numbers? 3 and 9. So I would do 3 squared plus 9 squared equals c squared. Okay, in your calculator, what is 3 squared plus 9 squared? Okay, it is 90. Very good. Now, if you wanted, you could find 3 squared, find 9 squared, add them together. That's totally fine too, but it comes out to 90. And so if 90 is c squared, then how do I finish out solving? Take the square root, which means that c is whatever the square root of 90 is. Now, if you put that in your calculator, you're going to see that it's a decimal. Okay, you can't type the answer in as a decimal though. You're going to have to reduce it using all the rules I just showed you. So peek back at your first sheet. We need a perfect square off of the list that 90 can divide by. Okay, I'll give you a hint. It's towards the top.
Right.
9 is correct. Very good. And remember, when we're talking about the list, we're talking about this side, right? The square root side. So 9 is going to be my guy. 9 times what will give me 90?
10.
9 times 10. And then what is the square root of 90? 3. So it'd be 3 root 10. Okay. And when you do your homework, the square root button should already be there for you to use. All right, let's do this one right below number 3. Should I start off with 2 squared plus 6 squared equals c squared?
No.
No. This is the other leg. So I'm going to have to do a squared plus 2 squared equals 6 squared. Okay, make sure that the hypotenuse has to be the c in the equation. The other two, the a and the b, it really doesn't matter which one's which, as long as you make sure that this guy is your c. So I have a squared plus 2 squared equals 6 squared. What do I need to do with the plus 2 squared? I'm going to minus it across to the other side. So I'm going to do 6 squared minus 2 squared, like that. However, if you want to find those numbers separately and then subtract it across, that's totally fine. So 6 squared minus 2 squared is going to give me 32. And then to solve, I'm going to take the. So I know that my a is the square root of 32. Okay, but that is not a perfect square, and I'm not allowed to put the decimal in. I have to do it in simplified radical form, is what your homework says. So go back to your little list. 32 is my guy. I want the biggest number off that list that 32 can divide by. 16 is correct. Now, can it also divide by 4? You have to pick the biggest, so it can divide by 4, but you want the biggest, so 16 is the correct guy to divide out. So it'll be 16 times 2. And then what's the square root of 16? So it'll be 4 root 2. Okay? All right, last question for us to take a look at is number 2. Only one leg is labeled with a 5. How will I know how long the other leg is? Yes, very good. So these little marks here tell you that both of these are the same. So if this one is 5, then you automatically know that one's 5, and then you would just do it the same. So my Pythagorean theorem would be 5 squared plus 5 squared equals c squared. In your calculator, add the 5 squared and the 5 squared since they're on the same side. What do we get for that? 50 is correct. And if 50 is c squared, then I'm going to take the square root. And I know that the square root of 50 is my answer. Okay, but if I put that in my calculator, the square root of 50 comes out to be a decimal, and I can't type a decimal in for my homework. So peek back at your list. 25 times what? 25 times 2. And then the square root of 25 goes to what? It'd be 5 root 2. Okay. We're gonna do them when we do log sine and cosines, but for capital letters, if you're interested in what the blanks are, that would be for angles. Lowercase letters are used to label the sides. And then corresponding sides and angles should always be across from each other. But we'll do some of those labeling and stuff in the next couple weeks.
So it's that simple.
That simple. Starting it off nice and easy. All right, so go ahead and get out your computers. Log into Delta Math for me, please.